Hi there guys, it's Mr. Poe from Autograph School for Boys, and in the 8th decision session we're going to be looking at critical path analysis. Okay, so what is critical path analysis? Well, suppose you've got a project, okay, with that's got a lot of intermediate tasks that need to be completed. In a specific order. And suppose each task has a weight, most commonly known as a completion time. Okay, so let's suppose I've got the following setup. Let's suppose I've got activities over here. And let's start with something very simple, A, B, C, D, E. And these 5 tasks are needed to have been completed in order to complete the entire project. Okay, and let's suppose that in the other column we're going to have prerequisites or tasks immediately before what's going on. So what do I mean by that? Well, let's say to begin with, task A can be done on its own, and so can task B. Then let's suppose that task C needs task A to be done, and task D needs tasks A and B to be done. And then let's suppose task E needs C and D to be done as well. Okay, at the moment I haven't added any weights. There's no weights to this. So, I don't know, let's make an additional column. And let's give this the weight. And let's suppose this is the time in days to complete a task if one worker was working on them. Okay, so one man days, if you like, or one person days working on it. So let's say task A takes 2 days to work, B takes 3 days, task C takes 2 days, task D takes 4, and task E takes 5. Then questions might arise from this, such as how long will this project take? Is there a minimum? And what's the fewest amount of workers you would need to employ? Okay, so critical path analysis is all about answering questions like this. Okay, when you've got an overall project and the project is broken down into individual tasks, and those tasks need to be completed in a specific order, and that specific order is set up with a precedence table over here. And the way you read a precedence table is if it's got a dash like that and a dash like this, then it's got no prerequisites. You can start task A and B on its own. And then they have weights, which is like completion times or the amount of man hours needed, or man days, or woman, whatever. The amount of time to complete that task, person hours, person days. It doesn't, I'm not trying to push any kind of like gender agenda. So, one way of writing this out is with a precedence table. But what you'll often also see is a diagram where we're going to calculate the early start, or the early finish, the early finish late start diagram, where we're actually going to calculate at which stage of the project do we need to be at certain points and what tasks need to be completed at certain times. So the way we're going to start this is we start off, these are the stages, so let's call this stage 1. It doesn't have to be labelled 1, but it's just a stage. And what we do is we split this into 2 boxes. The top is what's called the earliest, or the earliest we can be at this position, and the bottom box is the latest we can be at this position. So clearly when we're at the beginning, the earliest we can be is on day 0. But we're not actually going to fill these boxes until we've completed the diagram totally. So bearing in mind we've got activity A and activity B. Now the activities are not to be confused with the stages. At this stage we've got no activities done. So we can either have activity A going on, which will take 2 days, or we could have activity B going on, which is going to be 3 days. And generally speaking, these diagrams, you may need several attempts to draw these. It's not entirely easy to draw these kind of diagrams. So bear with me. So suppose I've got something like this. Now, we could potentially have a stage here, and we could potentially have a stage here. So I've done for A and B. Now look at C. C depends on A. So that means task C would happen after this stage. We'll call stage 2. So this is stage 1, stage 2. Let's call this stage 3. And the weight of C is 2. Okay. Now if I look at D, D needs both A and B. But look, each task has one arrow, so I can't repeat A over and again. So what I'm actually going to do is I'm going to create a dashed line from here to here, and this is called a dummy activity. And the way to spot if you need dummy activities is if we've reached a stage already and then that task is needed again. Now it's not immediately obvious, when a dummy activity is needed. In this case it is going to be, but in general you're going to have to draw your diagram and you're going to have to play around with it and think of what is the least amount of dummies that you've used so far. For me, a trick to spot that a dummy, from just looking at this table, that a dummy's needed, is if I've already got a prerequisite, let's say A, then if the next one just had A, for example like that, it wouldn't need a dummy. It's when you're using a task you've used before, but it's introducing a new task as a prerequisite as well that you'll need a dummy for. And then for the final one, because C and D are not in any of these previous boxes in this column, I know I'm not going to need a dummy for that. So once we've got A and B through a dummy, I now know that this is the task D popping out like so. And this has a weight of 4. Finally, I want task E. Well, it seems pretty obvious that it needs C and D, so both the C and D task must point to this stage here, which we'll call stage 4, and then task E is going to pop out of here, and then we reach the final finish state. And this E has a weight of 5. So if I was to tidy this up properly, my diagram would look like this. And now I have a completed early finish and late start time diagram that's ready to be solved. Okay, now the trick with this is you start with the early times and you work to the right, and then you do the late times and you work to the left. Okay, and you're probably thinking, what the hell are you on about? Well, let me do this example and then we'll crack on. So let's start with the early times. Well, the earliest we want to start in the top box is on day 0. We're at stage 1 on the 0th day. Now, if I do task 2, that means the earliest I can be here is at 2. Okay, so the earliest I can be at stage 2 is if I just complete task 2. Okay, now if I look at being at task 3, you'd think that I could get there either two ways. I could either get there from A and then a dummy activity which has 0 weight. So you'd think the earliest I could be there is 2. But think about it, to be at that stage 3, I must have completed A and B. So 2 days later, I've completed A, but I'm still 1 day I'm 1 day away from finishing B. So actually the earliest I can get to this stage is 3, and that is completing B. If I now carry on, I've now got this 2 plus this 2, which means I could get here at 4, but I've got this 3 and this 4, which means even if I was to get to stage 4 in 4 days, the earliest I could get there is in 7 days, because I'll be on the 3rd day from finishing B, and then D will take 4 days. So actually the earliest I can be here at stage 4 is 7. And then to get to the finish, because I only need to do part E, or task E, 7 plus 5 is 12. We've now worked from left to right. I'm now going to do the late times. And now let's suppose the latest I want to finish is on that 12 days. Right, so my project now, I'm aiming to finish on 12 days. I can do this project in 12 days. Well, it's very simple. I work backwards. If I've got a 12 here, and the only task before it is this task E at 5, that means I need to be at 12 minus 5, which is 7. I need to be at task 4 for the 7th day. Okay, that's a no-brainer. Now, if I look at this 7 and this task D, which is 4, that means I have to start at stage 3 on the 3rd day. There's what's called no slack. And the slack is a very specific term. It is just the late start time of one node minus the weight of the diagram, the weight of the task, and then it's also subtract the early start time of the previous stage. Okay, so slack isn't just something I'm making up, it's an actual term, and the slack is essentially, it's this number minus this number minus this number. So what is 7 minus 4 minus 3? That's 0. There's 0 slack, and that corresponds to that at stage 3 there is a difference of 0 between these two things, i.e. you cannot afford to be late on stage 3. If stage 3 is at day 4 instead of stage 3, then that 1 extra day is going to shunt on the finish time to 13 and so on. Now, if I look at the top task, if I've got 7 here at stage 4 as the latest I can be there, but C is only of length 2, that means the latest I can start C is 5 days on day 5. Because if there's only 2 days needed to complete C, and I need to be at stage 4 for 7, I don't necessarily have to start C straight away. Okay, and we'll talk about what C is and what it's not in a second. But essentially, 5 is the latest we can start going from stage 2. But let's crack on backwards. Now, if the latest here is 5 and we start there at 2, then that means this could be a 3. But the latest we can be here is 3, and this is 3 days, so now this actually is going to be 0. So whenever we're working to the earliest, we always want the largest early time, and whenever we're working to the right, we always want the smallest late. So we always want the largest earliest time and the smallest late. That's really important. Now, you know you've done this right when there's a couple of things going on. One, the start stage and the finish stage numbers are the same top and bottom. Okay, when that's the case, then you've done it absolutely perfectly right. Okay, when they're not the same, then you've made a mistake somewhere. Second of all, you'll notice that a couple of other stages are like this as well, and that is this stage here is the same top and bottom, and this stage here is the same top and bottom. Now, what this means is that we're going to introduce a concept called the critical path, i.e., these are the activities you cannot afford to delay without the overall project being late. And these are really easy to find. If they're critical, then their slack is 0. Another way of looking at it is those critical tasks are always going to be between 2 stages where the top number is the same as the bottom number. Okay, you have to be careful with dummy activities sometimes, so just, be aware, but the golden rule really is that when the slack is 0. Now, usually the path or the critical activities trace out a path, and in this case it's going along the bottom here. So I would say the critical path or the activities are B, D and E. So in this case, the critical path or activities are B, D, E. Okay, now that means that you cannot afford to be late with any of the tasks B, D, E, and as long as you get those perfectly on time and you're within the slack of the other task, which is A and C, then you're totally okay. Okay, for example, A is 2 days, but look, the latest we can be at this stage is 5. So really, that means A has a slack of 3. You've got wiggle room, if you like. A can be 3 days late if you want it to. And similarly, this task is 2, and the earliest we can be here is 2. So really, 7 minus 2 minus the earliest is 2. This means this also has a slack of 3. There's a 3-day wiggle room for C. Okay, so A and C are not critical because they've got some wiggle room. Whereas the other tasks, you can't afford to be late, otherwise they will delay the whole project. And essentially, this is pretty much critical path analysis. The only thing I'll say though is there's a couple of ways of expressing the results of this. And one of them is Gantt, or Cascade charts. And the other one is resource histograms. Okay, and essentially what we're going to be doing is saying, right, okay, how are we going to allocate the workers to actually do this problem? So with the Gantt chart, that's going to be fairly simple. I'm going to draw out my Gantt chart. So I start off at 0 and I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So that's day 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, so the important thing with the Gantt chart is the top row are just your critical activities. Okay, there's no getting around it. So for the top row, I'm going to need to draw boxes for B, D and E. So the earliest B can be is at 0 and it's 3 days. So 1, 2, 3, so it can end here. So B will look like this. Then it's D, and D is 4, so that's going to finish day 7. So 1, 2, 3, 4, like so. Now obviously you draw a ruler and you'd be given a table in your test. I'm just doing this freehand. So this is 3, 4, 6, 7, 2, 1, 8, 9, 11. And then finally E, it's 5 days, so that'll finish at 12. So something like this maybe. Oh dear. Wow. So that's task E. And now the other tasks will be drawn underneath it. Okay, so notice A can originally start at 0. So it can start at 0 and it's too long. So A is essentially this. Oh dear. Oh mate, come on. So A is a rectangle looking like that. But it's got a slack of 3 because the latest we can be there is at 5. So really what I need to draw is an extra rectangle like that goes up to 5. And that's supposed to be a rectangle. You shade this in. This is to denote the slack. Okay, sorry this is a bit dry. This is the slack. And then, well actually let's put the slack up here because I'm going to draw under that now. For a cascade diagram, I'd then carry on with the tasks and cascade downwards like so. So the next task will be C, and the earliest that can be is 2. So I'll start the box here at 2, and it's worth 2, so I can go all the way to 4, like that, so it's only 2 wide. This is task C, and the latest I can finish there is 7. So that has a big slack of 3 as well, and that's the slack of C. Now this is the cascade, right? If I wanted to do a Gantt chart and actually organise them into workers, then it's pretty obvious actually what needs to happen. Then what's going to happen is you slide these around. Now because C starts as A finishes, I can slide that up there like so, and everything will be fine. So now it's pretty obvious actually that if somebody asked you how many workers would you need, well, you can say you're going to need 2 workers, so you'll need 2 workers for the first 4 days, and then just 1 worker. Okay, so if somebody said to you, okay, so you can only have one worker per task, and each worker, I don't know, was £10, £10 a day. I don't know, not £10, £100 a day. I don't know, to do something, then then you could probably say to the people, well, okay, I'm gonna need £800 for the first 4 days up front to pay for the two workers, and then 4 to 12, well, that's 1 day, 2 day, 3 day, 4 day, 5 day, 6, 7, 8, and then I need £800 for the last 8 days because there's only one worker. A lot of it is just common sense, just reading off the diagram, figuring out what's going on. Another thing this is useful for is, suppose you've got, let's say you've got an inspector, and let's say that inspector comes on day 5. Then what I would do is I would draw a vertical line on day 5, and imagine this vertical line could be moved between day 5 and 6 like so. Now can you see that no matter where I slide it to, task D has to be happening. So task D has to be happening. It has to be happening. So put it this way, if the inspector comes along and task D hasn't been started yet, or and then the inspector could say, well, I've reason to believe that the project is going to fall behind. Being able to construct these diagrams is not that difficult. Maybe I'm teaching you how to suck eggs at this point, but just be aware. I mean, this thing I believe is the Gantt chart, and this thing up here is the Cascade. And the reason it's called the Cascade because the tasks kind of cascade down, and it's really important. The critical paths are the top ones. It's the complete top row. There's no slack. I've said that already. There might be 2 critical paths, i.e. 2 parallel critical paths, and in that case it doesn't matter if you have one on top of the other, as long as you've got a complete row and then another complete row. Resource histograms, well, this is kind of just, it's a much of a muchness really. You generally do this when, let's suppose, for no reason, let's say tasks B and D and E need 2 workers at all times, and let's say A and C only need 1 worker. Okay, so really the resource histogram is there when, mainly for when each task needs different amount of workers. So same deal, I'm going to have day 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And now what you do is you put the critical activities on the bottom row, and then what you do is you just represent 1 worker per task as 1 square. So really simply, I'm going to need, because B, D and E are all critical and they're 2 workers each, then I'm going to need 2 rows like so. Something like that, something like that, something like that, that, and B is up to day 3, so this will be B, 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 and then D is up to row 7, so that'll be D, 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 and then the final bit is E, so this is E, 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 E. Okay, and then the workers A and C, well, A is just 2, so I could just draw this as like this. So there's A and there's A, and then C is also 2, so I could do this. And then this is clearly for 1 worker, 2 workers, 3 workers, and you can just pretty much, you can just read off. So this axis is for workers, this is for days. Yeah, I mean, it's not particularly difficult. Because A and C have slacks, then essentially you can move A and C around a little bit if you want to be flexible. I don't know, let's say that for some reason the toilets don't arrive until day 3, and you know, you can only have 2 people on the site without toilets, and then when the toilets come, you're fine. Then what you would do is you just redraw this out again, and you just slide this over, so it could be there. Say, it's not difficult. There's no algorithm for it. You just kind of slide things along and see where they can fit. The one thing I would say though is the critical activities always do need to be on the bottom row. Okay, and that's pretty much it. So we've talked about precedence tables, we've talked about early finish and late start diagrams, how to calculate the early start times and the late finish times. The late start times and the early finish times. We talked about Gantt and Cascade charts. We talked about resource diagrams. There's probably more to it, but I think you'll find that just picking up the exercises that I've given you will probably, you'll learn by doing them. But talking about the idea of the critical tasks have a slack of 0, all that kind of stuff. I mean, I've given a crash course in it. It's just time to do some questions now. So here we've got a question. If you want to give it a go yourself, knock yourself out, pause the video. Just going to get a drink. Okay, so given this activity and immediately preceding activities chart, draw the activity network described in the precedence table above using an activity on arcs. That's a bit weird. Yeah, well, that's what we do anyway. Your activity network must contain only the minimum number of dummies. Okay, so we just have to be really careful. So I notice that A, B, and C have no precedence. So that means when we've got an initial stage, okay, let's say that's an initial stage, then that means I'm going to potentially have 3 activities popping out of it. Let's say A, B, and C. Okay, so they're done. There's nothing before them, so A, B, and C are the first ones. Next up, I see that D depends on A. So that means if I have a stage at A, like so, then there's going to be a D popping out of it, like so, like that. Now, don't panic with this. What I personally would do, pro tip, is I would use a pencil, okay, and a rubber, because, you know, getting these things right takes a lot of practice. I mess up all the time. You've got loads of time in the exam to do this, so just be careful and always just check to see if your answers make sense, especially when you think like, oh, I mean, technically you can do this with lots and lots of dummies, but you always want to kind of look to see what's the minimum amount of dummies. So what's up next? So I'm pretty confident that D's done. Now E depends on C, so that means if I have a stage at C, that means E is going to be popping out somewhere like that. Okay, and if you don't want to, you can just leave the arrows for a second and just put the letters immediately to the right of the boxes, like so. And then that just tells you you're going to have activities coming out of them. Okay, now if I look at F, F needs B, C, and D happening. But then if I also look at H, that also needs B, C, and D happening as well. So there's going to be a stage where F and H pops out. So let's say I've got an activity where F and H pops out, and then think about it, I need B, C and D. Well, it looks like I could put that here, and I could let D be the activity going from there to there. That would make sense. And then I would have a dummy from C up to there like that. Now the reason I'm not connecting E to there is because E is not in these preceding lists. So I can't have E connecting up to there. So that must mean E is pointing out somewhere else. So just by that, I've got F and H done, and that's okay. Now if I look at G, G depends on A. So that means G is popping out of this one as well. So I've got a G popping out of there. Okay, so I've now got potentially 4 activities popping out here. G at that stage at the top, F and H from the stage in the middle, and E on the bottom. So at the moment, I'd have used my pencil. I'm making things nice and clear. It's not getting too cluttered. I'm just taking my time. Everything's fine. So I've got those activities. Now it's just the last one. Now, this is where it's going to get interesting. I've got I and J coming from B, C, D and G. Well, how's that going to work? Well, I notice there's no F and H there. So that means I'm going to have to shuttle the F to the side a little bit. Whoops. Like so. Well, let's look at it. I could have a dummy from B, that would be fine. I could have a dummy from C, could I? Well, no, I wouldn't need to because it's already being dummied here, so that's fine. D. Yeah, and then I just need a connection from G, so there you go. I'm going to have this thing up there. So, okay, that's fine. So then I'm going to have G connecting it like this, and then I'm going to have a dummy from the middle one like that. So if I trace back the dummy, the immediate activities will be D, B, and you go back from that dummy C. So have I got B, C, D, and G? Yes. So now that task is fine. Now, the next one, it's got that again though, and you're probably thinking, okay, how can I get around that? Because, well, well, I could say that, I could have I and J popping out from here, that's fine. But then if I look at, okay, so I and J are taken care of. And now if I look at what K needs, it needs E and H. So that means I probably need a stage down here where E is popping off into there, so I can uncircle that, that's done. G is being done there. H, if I take F up there a little bit, H is going to be like that. So there's H. Mate, what's going on here? So H is there. I've still got an F coming out from somewhere, so that's interesting. So that means I'm going to have a nice long task there going on, something like that, F. And E and H, that's going to become a K. So I've got a K popping out of, oops, I've got a K popping out here. And then that's it. There must be a final stage. Now, I can't have, now this is important, I can't have you know, two lines parallel coming from the same stage. So what I'm going to do is I'm going to take the J, for example, and because it depends on the exact same thing of I, I'm going to create a dummy. So it's got the same stuff, and then that'll be a stage for J, and then that's J going down there like that. So actually, so I is this activity there, F is this one here. So in actual fact, I think I've done it now, and I'm pretty happy that I've done it with only 3 dummies. Okay, so this is with part A. Now, yeah. Cool. Right then. Okay. Given that all the activities shown in the precedence table have the same duration, state the critical path for the network. Okay, well, let's just all give them a weight of 1. Let's just give them a weight of 1 and see what happens. So if I give them all a weight of 1, then the earliest, so this will be a 0. Going to the right, this depends on a 1. To get to this second stage, I need to have gotten to the previous one plus D, so that's a minimum of a 2. This will be a minimum of a 1. And then you'd think it's this 1 plus 1 to make a 2, but I need the 2 and the 1. This earliest I can be here is at 3. The earliest I can be at this top stage is 2, because it's this 1 plus the 1, or the 2 plus a dummy, which is always nothing. The earliest I can be here is a 2, because that's a dummy. The earliest I can be here is a 4, I believe, because 3 plus this 1 is 4, but a 2 plus a 1 is 3, but that's too early, and 2 and a 1 is a 3, that's too early, and a 2 and a 1 is 3, that's too early, so that's a 4. So if I now work backwards with the earlies, with the finish times, that's a 4. I go back 1, that's a 3. So then that's a 3. The latest I can be here is a 3. The latest I can be here is a 2, because I need 2 and a 1 to make this 3. The latest I can be here is a 2. The latest I can be here is a 1, and then that's a 0. Cool. So, to help understand what the critical path is, this is the same top and bottom, so is this one, so is this one, so is this one, so is this one. So just double check that the ones in between them trace out a 0 slack. So we're saying between there and there is A, that's a slack of 0, so A, and then it goes to D, and then it goes H, because that's got a slack of 0, so H, and then it will go K. So the critical activities are ADHK, so the critical path in that order is ADHK. Cool. That's assuming that every activity is the same duration. It wouldn't be the same if they were different durations. Yeah, quite a tricky question. Right, so for this one you might want to pause the video, enlarge it maybe, see what's going on. Okay, let's go. So an engineering project is modelled by the activity network shown in the figure above. The activities are represented by the arcs, and the number in brackets on each arc gives the time in days to complete the activity. Each activity requires one worker, and the project is to be completed in the shortest time. Fine. So, calculate the early time and the late time for each event. Write down these boxes in the diagram. Okay, they even tell us what to do, and look, they've given it to us here. So, early time, this is a 0. The earliest I can be at this stage from A is 10. Earliest stage I can be here is 14. And then if you think about it, 14 and 5 is 19. But to be at this stage, I've got to have C done as well, which is 10, 11, which is 21. To be at this stage, the earliest it can be is 29. Moving on, 14 and 15 is 29, but 21 and 12 is 33. That's the earliest I can be there. 14 and 20 is 34, but 33 and 6 is 39. It's the earliest I can be at that stage. 29 and 16, I believe, is 45, and 33 and 10 is 43, so the earliest I can be there is 45. 45 and 9 is 54, 33 and 21 is also 54, and 39 plus 12 is not going to be bigger than 54, is it? What's that, 51? So the earliest I can be here is 54. Right, let's trace these all back. So if that's a 54, latest we can be there is 54. 54 minus 12 to be back here is 42. 54 back 9 is 45. 54 back 21 is 33. No, hold on. Whoa. So potentially 33 there, but 45 minus 10 is 35. And 42 minus 6 is 36. But we need to take the earliest late time, which is 33, so that's fine. Still needs to check. If I go back to this previous one here, 45 minus 16, I believe, is 29, so that's fine. 29 minus 8 is 21, and 33 minus 12 is also 21, so that's fine. If we go back here, 21 minus 5 is 16. 33 minus 15, what's that, 18, and then 42 minus 20 is 22, so the earliest out of those for the late ones is 16. 21 back 11 is 10, and 10 back 10 is 0, but 16 back 14 is 2, so the 0 would win there because we want the earliest of the lates. We want the latest earlies and the early lates. Okay. Right, so what do we want now? Calculate the early time and late time for each event. Write these boxes in the diagram below. Yep, I've done that, that's fine. B, state the critical activities. Okay, so critical activities. So this is one, well, that's a stage, 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 and this is a stage. Oh, we've got multiple things going on. So the slack for A is 0, so that's 1. The slack for C is 0, so that's 1. The slack for G is 0, that's 1. The slack for H is 0, that's a 0 slack. J is not a 0 slack because 45 minus 10 minus the 30, bottom minus middle minus top is not 0, so that's not slack. This is a slack, and K is a slack. K is slack 0, sorry. So the critical ones are A, C, E, F, G, H, I, J, K, M. So we've actually got multiple paths going on here, haven't we? We could either have a critical path of A, C, H, K, or I could have had a path A, C, G, I, M, like so. Yeah, there's multiple paths going on here. Well, there's two, isn't there? So yeah, find the total float on activities D and F. Okay, so for D, it's the late time at the next stage, which is 21, minus the actual activity, which is 5, minus the early time, which is 14. So 21 minus 5 minus 14 is 21 minus 19, so that's 2. And then for F, where's F? We do the late time, which is 42, minus the time itself, which is 20, minus the early start time, which is 14. So what's that? 42 minus 34. That's just going to be 8, isn't it? 42 minus 34 is just 8? Yeah, 8. So the float on F is 8 and the float on D is 2. On the below diagram, lol, good English, draw a Cascade or Gantt chart for this project. Okay, this isn't a particularly well-worded question, I think, because there is a subtle difference between a Cascade and a Gantt chart, but whatever. So it's important to note that A, C are like the first critical two ones. There's no room for error there. So 100% up to 10, like so. This is A. And then C takes me up to 21, which is here. That's C. Let's make this a bit thicker, I'll be here all day. And then it could have gone one of two ways. And I'll show you what happens when it splits. G is 8, so let's do G up to 29. So let's have G there. So that's G. And then I is 16, so take me up to 45, which is there. That's I. And then M goes up to the remaining 54. That's M. But now if we go back to the split, we could have had H as 12. So we'll go there, and then the 12 takes me up to 33, which is here. So I'll draw a straight line from there to there. That is H. And then K is the remaining 21, so I'll draw a little line in there, create the ruler like that. That is my K. Okay, those are my critical activities, and they take priority on the top row. Absolutely fine. And now I'll just cascade the rest. So B can potentially start at 0, and it goes up to 14, which is here, but it's got a float of 2, 16. It could go up to 16, so I put a little box like that and shade it. And now this is my box B. This is B. Okay, so that's B done. Give it a tick. D, the earliest it can start is 14, which is here. And it's of length 5, so it could go up to 19, which is there. But it's got a slack of 2 because it doesn't need to be at the next stage until 21, so that's got a slack of 2. By the way, everything below the critical activity should have a slack. So if you're drawing boxes below the critical path and there's no slack, you're definitely doing something wrong. So that's D. Alphabetically, let's go E. So that could start at 14 as well. So there's E. And then it's 15 long, so it's going to take me up to 29, which is here. You can probably get the idea what's going on here. I'm just being thorough. So this is activity E. And 33 minus 15 minus 14 is the same as 33 minus 29. That's got a slack of 4, or we can just take this up to 33, which is here. So it's got a big slack there of 4. So that's E done. Let's go F, so that can also start at 14. And it's 20 long, so it's going to take me up to, oh, hold on, 34, yeah, which is up here. So there's F. And the latest I can be there is at 42. Wow, that's a big slack. Really? 42 minus 20 minus 14 is a slack of 8. Wow, okay. So where's the 42? That's all the way up here. So I'm going to shade this bit all in. That's a big slack of 8 there, so there's plenty of leeway for that task. That's F done. J next, so J starts at 33, that's the activity before it, so let's go here at 33, and it's 10 long, so it's going to go to 43, which is here. So this is J, and 45 minus 10 minus 33, the start time is a slack of 2, so I'm just going to bring this up to 45, which is here. It's got a slack of 2. That's J done, and I think it's just L and N left, so L starts at 33 as well. And it goes up to 39, which is here. So that's L. And it also goes up to 42. So that's a slack of 3, isn't it? It's L done, and then N, earliest start times, that's a 39, which is down here, and it's 12, so 39 add 12 is going to go up to 51, which is, oh, these lines are hurting my eyes. There's 51, so this is N, and then that can go up to the 54, which is here. So that's got a nice little slack of 3. Cool. On the below, so hold on, find the total slack, done that. State the critical activities, done that. Drawn the thingy. Okay. The chief engineer visits the project on days 15 and days 25 to check the progress of work. Given the project is on schedule, what activities must be happening on these 2 days? Okay. So if I was to visit on day 15, that would be a line that's skewering this thing here, like so, yes? It's between the 15 and 16 day. So if I was to slide this along, then, now, I think the only thing that has to be happening on day 15 is just C. The reason for that is because you can slide D 2 spaces along, yeah, because of the slack. So actually D might be starting on day 16, and E and F have massive slacks, they could have been delayed massively, so that's fine. So on day 15, C has to be happening. On day 25, if I move this to day 25, so that's all the way over here, it looks like G and H are happening, and there's no way to avoid it. On day 25, you've got to have G and H happening, and you also have to have E and F happening. Because think of E and F sliding. Think of the white boxes as the E and F buttons, and the slack, which is the black recess, as kind of like where the buttons can be slid to. So the buttons can be slid between here and here. They're like slider buttons. And clearly there's no way you can move E and F between their 2 proximities and avoid that line. So E and F have to happen as well. So yeah, that's my reasoning for that. Oops, daisy. Cool. Okay. Well, how's the time going? Yeah, we've got time for a couple more. Okay. So, pause the video, give this one a go yourself. Okay. The network in Figure 3 shows the activities that need to be undertaken to complete a project. Each activity is represented by an arc, and the duration of the activity in days is shown in brackets. The early event times and late event times are to be shown at each of the vertex, and one late time has been completed for you. The float for activity H is 7 days. Explain with detailed working why x equals to 11. Okay, so let's think about it. If this was 0, let's start working to the right. Then the earliest I could be here is 8. The earliest I could be here is also 8 because I need that dummy as well, right? It's the 6, but I also need to be at this stage first. But also, technically, I could have been here at 7 because of C, but then that's a dummy. But I'm still waiting on the A, which is an 8, so that's fine. I jumped the gun, but it worked out all right. Now, next up, if I look at this, for example, the float is 7. So that means the late time, which is 25, minus x, minus the early start time, which is 7, this must equal to 11. So on the left-hand side, I'm going to have minus x, and then 25. Sorry. No, what am I talking about? The float is 7. That's 7. Well, if I add 7 to both sides, and I've got 25 minus x equals to 14. If I rearrange this, I get 25 minus 14 equals to x, so x is clearly 11. The float is 7, so that means x is 11. So I can rewrite this 11, that's not a problem. Determine the missing early event times and the late event times, and hence complete the diagram in your answer book. Okay, well, there was also this stuff if you wanted to, but I'm just going to do it up here instead, actually thinking about it. So, the earliest I can be here at this thing, because it only depends on that, is going to be 18. Now, let's think about what's happening in... Well, this is depending on this as well, so I need to go back a step. 8... That's 11. This box only depends on the 11, so the earliest I can be here is 19. Now 19 and 6 makes it 25. 8 add this 5 is 13. 8 add this 8 is 16. 7 plus 10 is the 17. And the 18 plus a dummy is nothing. So out of 13, 16, 17, 18, it's the 25 that's slowing things down. So this has to be a 25. Okay. Now this box only depends on this I, so 19 plus 6, that's 25. Now if I look at this last stage here, then 18 plus 6 is 24. 25 plus 7 is 32. 19 plus 4 is 23. 25 and nothing. So out of 25, 23, 32 and 24, 32 is when all 4 of the things will be done by. So the earliest this can be is 32. So let's take this as 32 going backwards. Well, has that made sense? Well, no, it can't be. I think I've made a mistake here, because 32 back 6 is 26, and I've got a 25 there. Really, this should be a 31, so have I done some bad math somewhere? Let's think about this. Let's check one at a time. That 8 must be correct. This must be an 8 because it depends on these two things, and 8's the bigger one. This has to be a 7, so that's fine. 8 plus 11 is 19, so that's correct. 19 plus 6 is 25. 8 plus this 5 is not going to be bigger than 25. 8 plus this 8 is 16, that's not bigger. 7 plus 10 is 17, that's not going to be bigger. 7 plus this 11 is 18. So yeah, this 25 is legit the biggest. 18 plus 6 is 24. 25 plus 7 is 32. Am I being silly here? Okay, I've just been discussing with the answers, and this is indeed 32. And I get how 32 minus 6 is 26, and that's 25. So it's a little bit confusing, but maybe there's a constraint on this stage here that we don't know about, and the latest we can be there is 25. Not quite sure why, but the mark scheme is definitely ending in 32. So if we work backwards and look at the late times for the rest of these things, this will be 32 because that's a dummy. We can either go 32 back 4, which is 28, or 32 back 6, which is 26. So the very latest we have to be here is 26. No, that's not true, because, hold on, we've got this 6 to take care of as well, so we need to go back a little bit. 32 minus 7, that's 25, so 25 minus 6 is 19, so yep, that's 19. If I go 18 back 11, oh, that's going to be 7, but 25 back 10 here is 15. But I have to look at this thing here, that's not a 1. 25 back 8 is 17. Oh, sorry, it's not the 18. It's 25 minus 11. This has to be a 14. So yeah, this has to be a 14 because I want the earliest late time. This one has to be an 8 up here because 19 minus 11 is 8, and 25 minus 5 is 20, and 17 back nothing is 17, so the earliest late time is an 8. And then this has to be a 0 by definition. So determine the missing early event times and late event times, hence complete the diagram. Yep, that's done. Each activity requires one worker and the project must be completed in the shortest possible time using few workers as possible. Calculate a lower bound for the number of workers needed to complete the project in the shortest possible time. Okay, well this is pretty easy because this is just going to be the total weight of all the network divided by the weight of the critical path, right? The reason for that is because we're always going to have on our Gantt diagram one row that's our critical path, and then we can't, create another row that would be longer, so we will just want to keep adding as many rows as possible that's either the critical length or shorter. We can't have a row longer than the critical path because then it's not critical anymore. So the total weight, what is the critical path length? That's easy. It's over 32. The total weight is going to be A is 8 plus B is 6 plus C is 7 plus D is 11 plus E is 5 plus F is 8 plus G is 10 plus H is 11 plus I is 6 plus J is 4 plus K is 6 plus L is 7 plus M is 6, and we get the value of 95. And 95 divided by 32 is 2.968, which I'll say 2.97. So we're going to need 3 workers. Okay, that's the, that if you need 2.97 optimally, then you're going to need 3 workers, right? Schedule activities using grid 1 in the answer book. So we're going to need to schedule them by doing this stuff over here. Okay, so first of all, what are the critical activities? Well, this stage is even, that stage they're the same, this stage is the same, and this stage is the same. So which ones have a float of 0? Well, that's A, D, K, and L. I believe A, D, K, and L. Okay, so if I was to do that, I'll try and do it all in one go. Maybe I should have had A, D, K, and L there. Maybe I'll just copy this down. So 8, 8, 8, 17, 19, 19, 25, 32, 32, 32, 25, 25, 18, 7, 14, 0, 0. Okay, so 8 will start at 0 and goes up to 8. That is terrible. So this is A. D is the next one, that goes up to 19. So it's going to be something looking like that. So that's D. And then K goes up to 25, so that's K. And L goes up to 32. Okay, now this is a scheduling thing, so we really don't really care about a cascade. We just want to get them. We know we're going to need at least 3 workers for this, so don't panic. Well, B and C look like they need to be done at the same time. So if B is 6, let's put B here. So that goes up to 6, and C is up to 7. So then let's make that one a C. Next up, so we've done B and we've done C. Well, what have we got next? E needs to start at 8, F needs to start at 8, and G needs to start at 7. So because C finishes at 7, let's have this G starting at 7, and it's worth 10, so it's going to go up to 17, which is here. So that's G. So that's G done. And then I've got E and F. Well, they both have to start at 8 minimum. So really, we're going to have one there. Can F be slid along? Yeah, F can be slid to 19. But it looks like H as well can start at 7, go up to 14. I think F being 8 long, if you slide that, yeah, that's not ideal. So what I'm going to do is I'm going to have E there. So that's up to 13, so that's E. And I think I'm going to have H start as early as possible, so that's 7. And H is 11 long, so 7 up to 18, which is up here. So that's H. So that's done. G's done, E's done, A, B and C are done, so I've got F, which is 8 long. Well, actually I could start that after E, that's the next earliest one, so 13 plus 8 I believe is 21. So that's nice, that's where F can slot, so F is done. And now I've done kind of like this wave if you think about it. Let's have a look next. I has to start the earliest at 19, but it can be later actually, so I think I'll put I up here, so I is 6, so 21 plus 6, that goes up to 27. So this is my I. That's done. What else could I have? I think I could have J and M, couldn't I? Yeah, I think I can whack J and M in there. So because I'm at 17, I think I'll put M here, because M will be ready just as H finishes. Yeah, that's fine, and that'd be 6 long, so 18 plus 6 is 24, so that's where M is, so this will just have to be downtime. And then I can have J for 4 afterwards, so that's 24 to 28. That's where J is. So that's J and M done. And I believe that's everything. I've got A, B, C, D, E, F, G, H, I, J, K, L, M. Yeah, that's it, done. That's one possible way. I could have swapped J and M over because they don't depend on each other. It's not like one precedes the other. So really I could have swapped them over arbitrarily. It doesn't particularly matter. You know, it just meant that worker 3 would have a bigger break here, but it would have gone on for longer. I don't think we can make this any more optimal. Well, just because there's also slack here, sorry. It doesn't look like I can slide these things around so much. And the reason, well, E, G and H are happening at the same time, so I think we're a bit stuffed there. Cool. All right. So I think that's D done. Aha. Okay, last one. So if you want to pause the video and give this a go yourself. Okay, so I think I need some space for this. So the activity network, what's going on? Add page. No? Okay. Right. The activity network opposite shows the activities involved in assembling a particular vehicle on a factory production line. The times shown are in hours, and the latest start times and the earliest finish times are shown at the vertices. A. Draw a Gantt chart for this network. Okay, so where are the critical... So that's... They're the same numbers, they're the same numbers, they're the same numbers, they're the same numbers. It doesn't look anywhere else. So the floats, that has a 0 float, that has a 0 float, this has a 0 float, this has a 0 float, this has a 0 float. So immediately I can tell straight away that my critical path and activities are A, D, I, O, P. Adiop. So it's going to be 30. Oh man, do I have to draw this? So 37. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That's 10. 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. That's 20. 1, 2, 3, 4, 5. Let's make 25. 6, 7, 8, 9, 30. 1, 2, 3, 4, 5, 35, 6, 7. 1, 2, 3, 4. Let's make that 5. 1, 2, 3, 4. Let's make that 15. Oh, these are not particularly well spaced. Never mind. Okay, so if I was to do this, well, for a start, the exam would have given me, they would have given me something to write on. So I'm wasting a bit of time here. So A is 9, so that means I'm going to have a box like this. So from 9, like that, that's A. Then D is 6, that's going to go up to 15. Actually, might as well just draw a long thing up to 37, like that. This is D. Then I is 8 up to 23, 1, 2, 3, so that's I. And then O is 5, so that's up to 28, 9, 28, so that's O. And this is P. So that's the A, D, I, O, P done. Right, okay, let's do B and C. So B and C, B's 5. So there's B. And it's got a float of 6. Wow, so it can go all the way up to 11. So it's got a massive float. C has also got a length of... Wow, okay, C has got a massive... Oh, mate, come on. I mean, do I have to draw this? I mean, you should get the idea by now. I'm a bit bored. I've got 27 minus 5, which is 22. So I can just go up to 27, 6, 7, which is up here somewhere. There, down a bit, along, like that. And this is all slack. This is my float, my slack. So that's C done, that's B done, D's done. What about E? Well, E can start at 5, so there. And it's 4 long, so I could go up to 9, which is here. So that's E. And that's got a flow of 15 minus 4, which is 11 minus 5, 6. I can go up to 15. So here, it's got a slack of 6. So that's E done. F is the same deal, starts at 5. It's got a weight of 3, 6, 7, 8, so it's going to be there. That's F. And then, wow, the latest that can be is up to 30. It's all the way up to here. Oh man. It's very tedious. Easy but tedious, as long as you don't make any mistakes. So F has got a great big amount of slack here. So it goes up to 30. So that's done. Then G can also start at 5. Wow, and it's also got a slack of 30. So essentially I'm just copying out this box again. That's G. And this is all slack. Okay, next up, H. We start at 15, which is over here. And it's 6 long, so we're going to go up to 21. That's H. And it's got a slack of 1 because we can go up to 22. So that's H done. J starts at 8. Maybe I should have done that back here, maybe. So 8 is about here. And it's got a length of 1. So that's J. Wow, you can go up to 31 with this, so it's going to go like that. This is going to be a massive one up to 31. I should have cascaded these properly. H should have gone below J. You're not going to be penalised for it as such. Still correct. And then N, well, that's going to start at 21, which is over here. It's worth 6, that's going to go up to 27, which is over here. That's N. It's going to have a slack of 1. That's N done, and then M can start at 9. It's got a length of 1. So that's M. That's got a slack of 37, so that's all the way to the end. This is all slack. So M is really, it's really easy. K starts at 9. Same deal. Oh, have I done that on the 8? Yeah, I have. That should really be on the 9. Yeah, it's getting a bit. This is the 9. This is the 8. Okay, and that's 1. I can go up to 32, which is over here. So that's all slack. Then L starts at 10, which is over here, and that's length 4, so it's going to go up to 14. So that's L, and that can have a slack up to 36. So that's 1 away from the edge. So that's a load of slack here. And then Q starts at 14, which is immediately after L, and it's of length 1, and you can go right up to the edge, 37. So that's Q. Okay, so that is my rather horrible and demented Gantt diagram. But yeah. Draw. Okay, the number of workers required for each activity is shown in the table. Okay, so 1 for B, C, E, F, G, H, L, and Q, 2 for A, D, K, J, M, N, O, and 3 for I and P. Draw a resource histogram for this project, assuming that each activity starts at the earliest possible time. State the number of workers needed in this instance. Oh man, this is lame. This is so lame. Okay, fine. So I'm going to have to do a very similar thing. Right. Oh, is there a way to have grids on here? There must be. No. God damn it. Okay. Well, let's have workers up here. That is terrible. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So that's day 10. 11, 12, 13, 14, 15, 16, 17, 19. That's day 20. 1, 2, 3, 4, 5, 6, 7, 8, 9, 30. 1, 2, 3, 4, 5, 6, 7. Whoops. Okay, so A needs 2 workers. So let's get the critical path down. So from 0 to 9, which is what A is, I need 2 workers for A. So I'm going to need 9 days. So that's going to be like that, across there like that, and then across along here like that. Now I'm probably going to need 2 workers on everything, so actually let's just do the bottom row. Let's get this over and done with. Okay, so this is all A. This here are the 2 workers that were needed for A. So A. So it's very, very tedious. Okay, that's my A done. For D, that also needs 2 workers. And D, remember, was 6 days, and that takes me up to 15. So 11, 12, 13, 14, 15. So I'm going to draw a straight line like that. Straight line like that. And then these are all D's. So D, 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 D. And then I was the next one. Well, that needs 3 workers. Okay, so I need to draw 3 high. And I was 8, so up to 23. So 1, 2, 3. So there it is. Let's have a nice I there. So I'm going to go up an extra 1, like that. And now this block are all I's. Yeah, resource histograms. Boring, tedious. You just let a computer do it. I doubt very much an exam question would be on this kind of thing. It'd probably be, and the exam question would probably be something like, here's a resource diagram, spot a mistake with it. And once you've done about 20 of these, you're like, oh, okay, I get what's going on. They're really boring and tedious to construct. You just let a computer do it. But the critical path just goes along the bottom. And then O was 5 long from 23 to 28, so that's 29, so this is 28. And O had 2 workers, so I'm going to need 2 rows here, like so. So that's going to be like that, like that, like that, that. So these workers are all, these 2 workers are working for this time on O. And then the rest is on P. That needs 3 workers. Okay, so I need to go back up to 3. Like that. Mate, come on. So this is all the P. Yeah, sorry this isn't magical, but unfortunately this is an area of maths that computer programmers really love. It's pretty useful. When you understand it, it does make programming things a lot easier. So this is P, 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 P. Lots of P's, P's everywhere. Okay. So I've done my critical activities, and then the questions clearly said, assuming that each activity starts at the earliest possible time. So B has one worker and it starts at 0 and it's 5 long. So 1, 2, 3, 4, 5. So we'll put B in next. So this is all the B's. B, 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 B. And then C's, it's the same deal, isn't it? They've just got one worker. So that's the B and C done. The E's are going to start off to 5 and they're 1 workers. F and G are also going to start from 5, so you need E, F and G stacked on top of each other. E is 4, F and G are 3. So 1, 2, 3, 4, that's where E is going to be, because that's 4. Oh mate, come on. But then I'm going to need 2 of these for the F and G. It's really bad. So these are all E's. These are all F's. These are all G's. Now I've done my E, F and G. J was the next one. J could start at 8. So that's 10, 9, 8. So I guess J could slot in there. Mate. That's J. J is 2 workers, so I need to slot that up 2, like so. So hold on, maybe I should be crossing these off as I go along. So I've done A, I've done D, I've done I, I've done O, I've done P, and I've done B, and I've done C, and I've done E, F, and G, and I've just done J. Okay. What else have I got to do? M and K. So M will start at 9 and so will K. So M was 2 and K was 2. So I'm going to need 2 there. No. And then another 2. Like that. Split in half. So this is K. This is M. And M and K are both 1, so that's done. So I've done M, K. Where's H? Oh, H is not till later. L is next according to the chart. And L, where is L? L starts at 10 and it's 4 long. So L is 1 worker. It starts at 10, which is here, and it's 4 long. 1, 2, 3, 4. So it's going to look like that. This is L, 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 L. Something like that. Okay, so that's L done. And then the next one's a G and H. Oh no, what's this one? Oh, that's Q. Jesus. Q. H, Q, and N. Okay, H and Q. Okay, H is... Where's H? H is 6 and it's 1 worker and it starts from 15. So 10, 11, 12, 13, 14, 15. So H can start up there and H is 6 long. So 1, 2, 3, 4, 5, 6. That's 1 worker. So let's put H in there like that maybe. Oh mate, come on. Okay. H is 1 worker and it's 6 long. So this is H, 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 H. As my H is done, my Q is 1 worker and from 14. So 10, 11, 12, 13, 14. Oh, that's nice. That means Q can just slot in here. That's not a problem. And then the last one is N, which is 2 workers. And N is up here. It's 6, starting at 21. So this is 21 here. Oh, okay, so what happens here? So we'd have 1, 2, and then 3, 4, 5, 6. Okay, so N, N. So you're allowed to do that. They're allowed to drop down. They don't just like spread across the top like that. Okay, so it looks like if you were to just do them, draw a resource okay, back it up. Draw a resource histogram for this project. Check, done it. Assuming that each activity starts at the earliest possible time. Done that. State the number of workers needed in this instance. Well, K, M and D, do they all need to be starting at that time? Yeah, K needs to start at 9, M needs to start at 9, and D needs to start at 9. They all start at 9, and K, M and D all are 2 workers each. So the max amount of workers at any time is 6. You will need a maximum of 6 workers, and that will be on the 9th day. Clearly, you know, you'd probably want to shuffle this around a little bit, maybe. But yeah, it looks like 4 workers for most of it. You could probably swift this around, but at one point you're going to need 6 workers. And yeah, being able to move this around, there's no algorithm to it, you just give it a go. Okay guys, sorry if that was a bit slow, but yeah, that's essentially this chapter. So early finish times, late start times, calculating the float on an activity, resource diagrams, Gantt charts, precedence tables, and trying to write up relationships, spotting when dummy activities are needed, that kind of thing. Yeah, I hope that was useful. All right, toodaloo, bye-bye.